Today we will see Chapter 3, Section 3.7, Graphing Linear Inequalities. And the first objective is to graph linear inequalities. We have linear inequalities in two variables. They usually have this form. ax plus by is the inequality here, let's say less than c. And this inequality can be less, can be greater than, can be less or equal, or greater or equal. A, B, and C are real numbers. A and B are not zero. Let's go to the step-by-step in how to graph the representation of this inequality. First thing, you have to graph the boundary. And the boundary is going to be, if you have this kind of inequality here, the boundary is going to be the equation ax plus by equals c. Find the line that represents this this boundary here, this equation here, and let's draw a line that we're going to suppose that represents this equation. Let's say this line. One thing that's really important when you draw the line, first you check the inequality. If the inequality is greater than equal or less than equal, it's going to be a continuous line. If the inequality is just less or greater and you don't have the equal sign, let's say you don't have the equal sign, then the line is going to be dashed. It's going to be a dashed line. Something like this. Okay? And this line goes to infinity. Don't forget also the arrows, because this line goes to infinity. And so this situation here is going to be dashed because this is, we're going to keep this as a greater than c. Okay. Next step. Choose a test point. Usually you're going to choose the test point 0 and 0. Unless this is in the boundary. I mean, the line goes through here, the origin goes through the point 0 and 0. So you're not going to be able to use x equals 0 and y equals 0. But otherwise, usually the best way is using 0 and 0. And you plug in a times 0 plus b times 0 is greater than c. Okay, this is just the line, the boundary. Now we have the inequality. And we're gonna check here if this is true. 0 is greater than c. Suppose this is true. If yes, true. All this area that where the point is located is the representation of the inequality. If it's true, and if it's not true, if it is false, then it's going to be the other area. It's going to be the opposite area. Let's say it's false. Then all this area here is the representation of the inequality. Okay? So Step 3, if a true statement is obtained, shade the half plane that contains the test point. If a false statement is obtained, shade the half plane that does not contain the test points. Let's go to an example, and we will understand everything with this example here, where x minus y is greater than 3. Okay, x minus y is greater than 3. Let's draw the line, the boundary, and the boundary is going to be x minus y equals 3. This is the boundary. First thing I'm going to ask you is, the boundary is going to be continuous or dashed? Check here this inequality. It doesn't have an equal sign, right? There's no equal sign here. No, no, no. So it is going to be dashed. X minus y equals 3. Let's say x equals 0. If x equals 0, y equals negative 3. If y equals 0, x equals 3. So first order pair, let's get this one. 0 and negative 3. 0 and negative 3. 1, 2, 3. Negative 3. Y equals 0, x equals 3. 1, 2, 3. Underline. Let's make the line green. The line is going to be, is it dashed or continuous? Dashed, because there's no equal sign here. So dashed line. I know, no equal sign, dashed line. And now the next step. Check the step again, step by step again. Choose a test point, not on the boundary. Can we use 0 and 0? X equals 0, y equals 0? Yes. Let's use 0, 0. Let me erase this here, this thing here. And let's do let me erase this too. Test point 0 and 0. So x equals 0 minus y equals 0 is greater than 3. 0 greater than 3. Is it true? Is it false? It's obviously false. That means the point is here. This area on this side of the line is not the right area, because the statement is false. So the right area, the representation of this inequality, is the area where the point is not located. That means this area here. And don't forget, this goes all the way to infinity. Infinity, infinity. And this dashed here is going all the way to infinity. Okay, this is the representation of what? That inequality. X minus y is greater than 3. And that's to check with the PowerPoint. Now another example. Now we have x minus 4y is less. So this example, x minus 4y is less or equal than 4. Step 1 is the solid line or continuous line or dashed line. Solid or continuous or dashed. Check it out. There's an equal sign here, right? So let's find the line. Minus 4y equals 4. And it's going to be continuous line. If x equals 0, y equals 0 minus 4y equals 4. So y equals -1, right? How do I know this? 0 minus 4y equals 4. Divide everything by -4. Y equals -1. Okay? What about if y equals 0? If y equals 0, x equals 4. Let's plot the line. X equals 0, y equals -1 here. And y equals 0, x equals 4. 1, 2, 3, 4. Get the ruler and make a line connecting these 2 points. Okay, and the line is going to be continuous. The line is going to be continuous. Which points are you going to use? To test any point that's not on the boundary. Any point that's not on the boundary. But we're usually gonna use 0 and 0, x equals 0 and y equals 0. So let's plug in here. Let me erase this. X equals 0 minus y equals 0 is less than or equal than 4. 0 is less or equal than 4. What do you think? Is this true or false? True, right? That means you have to shade, you have to choose the area that's where the point is located. So all this area here is the representation of the inequality. And this goes all the way to infinity. Remember, this shade here goes all the way to infinity. Which inequality are we representing? X minus 4y equal less or equal than 4. Okay? Another example. 3x plus 5y is less or equal than -2. Next example, graph the inequality. 3x plus 5y is less or equal than -2. So, step by step, first step, graph the boundary line. So let's go here to the boundary line, which is going to be 3x plus 5y equals -2. This is the boundary line. Is the boundary line continuous or solid or dashed? If you have this equal sign here in the inequality, then it's going to be solid or continuous. line. Okay? Let's find the points here to graph the line. If x equals 0, you're going to have 5y equals negative 2. Y is equal to negative 2 over 5, right? And if y equals 0, 3x equals negative 2, x equals negative 2 over 3. Let's go to the coordinate system and plot this. And we have x equals 0 and y equals negative 2 over 5. And this is, let's say, here is a negative 1. Here's negative 1. Okay. And we have first one, x equals 0, y equals negative 2 over 5. X equals 0, y equals negative 2 over 5. So we divide 1 into 5 bits, 5 equal segments, and get 2. This is going to be negative 2 over 5. This. Okay? And the other point, the other order pair, is going to be y equals 0 and x equals negative 2 over 3. So let's divide this segment here into 3 parts, equal parts. 1, 2. 2 over 3 here. Here, this is negative 2 over 3. And we can draw the line, get the ruler. The ruler goes through these points, those points. Let's use red, and this is the line. It's continuous or dashed, solid or dashed, solid line, because of the equal sign on the inequality. And remember, these lines here, they go all the way to infinity. The line need to have these arrows to represent that they go all the way to infinity. Okay, next step. Let's check the next step. Step 2, choose a test point, not on the boundary. So our test point is going to be the traditional test point, which is not on the boundary, 0 and 0, x equals 0 and y equals 0. And let's plug in this on the inequality. The inequality is here. Okay, 3 times 0 plus 5 times 0 is less or equal to negative 2. Let's check if this is true or false. 0 is less or equal to negative 2. What do you think? Is this true or false? False, right? Because 0 is greater than negative 2. That means the points, the ordered pair 0 and 0, they are not in the area. It's going to be the other area. The area that does not contain the points, which is going to be this. Don't forget, this goes all the way to infinity. We're just representing a small piece of the inequality of the graph. This goes all the way to infinity. Let's work another example. Now we have 3x is less than 15. This example, graph 3x. Let's use 3x is less than 15. First step, the boundary, find the boundary, and the boundary is going to be this line here, 3x equals 15. 3x equals 15, divide both sides by 3, x equals 5. This is the line. Important question, is this line going to be solid or continuous line or dashed? What do you think? Always check again the inequality. If there's no equal sign here, then it's going to be no equal sign, it's going to be dashed line. And you go here where x equals 5. 1, 2, 3, 4, 5. This is x equals 5. And this is going to be, this is a typical vertical line equation, right? X equals 5. Now remember, dash it. You need the dashed line. This is going to be dashed because there's no equal sign on the inequality. It's not an inequality that's greater or equal or less or equal. This, in this case here, is just less than 3x is less than 15. So no equal dashed line. Choose a test point, and our test point is going to be 0 and 0 most of the time, unless the boundary crosses the, or origin crosses this 0 and 0 point. Here, plug in the inequality. 3 times 0 is less than 15. 0 is less than 15. True or false? True. That means the area where the point is located is going to be the area to be dashed. It's going to be dashed. Is the area that represents the inequality. Okay? Never forget, this is just a small piece of the graph. This goes all the way to infinity. Another graph, another example. Y is less than 2. Graph y less than 2. First, find the boundary. And this is odd because this is not solid at all. So this PowerPoint is wrong. Graph the boundary, and since there's no equal sign here, see, no equal sign. It's only gonna be solid or continuous if you find an equal sign here. So this is going to be dashed. Wrong, not solid boundary. The line is going to be y equals 2. Let's go here, 1, 2. And this is the boundary. The line, a horizontal line, y equals 2. Now remember, check here the inequality again. I'm pretty sure it's dashed. Okay. All the way to infinity. Now choose the test points. Test point can be 0, 0. Yes, 0, 0 is not on the boundary. So apply plug in 0 here. 0 is less than 2. What do you think? True or false? True. Great. So we can dash the area where the point is. All this area here, all the way to infinity. Okay? Don't forget, this PowerPoint is wrong. This is not a solid. It's dashed. And here is dashed. Another example. This example is graph y less or equal than 1 over 4 times x minus 3. Let's graph the boundary, and the boundary is going to be this line here. And the question, dashed or solid? Solid, right? Solid or continuous line. Because we have this equal sign here. And the line is, let's first make x equal 0. Y is going to be negative 3. And for y equals 0, x, let's say 0 equals x times 1 over 4 minus 3. Add 3 on both sides. 3 equals x over 4. Multiply both sides by 4. X equals 12. Okay. So let's represent it here. If x equals 0, y equals negative 3. 1, 2, 3, negative 3. X equals 0, y equals negative 3. And if y equals 0, x equals 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's extend the x-axis here up to this point. Okay, and 12. Connect the lines, the points, I mean. Draw a line through both points. Let's use red. And don't forget to represent the arrows. That means this goes all the way to infinity. And the last step, that's gonna use our traditional test point, 0 and 0. Let's plug in 0 and 0 here. So we have 0 is less or equal than 1 over 4 times 0 minus 3. 0 is less or equal than negative 3. What do you think about it? True or false? False, right? Because negative 3 is less than 0. What does it mean? If it is false, this point here is not in the right area. The right area is the other one. When it's false, you have to shade the other one. The area that does not contain the test point. So this area here is the representation of the inequality. Okay, the inequality y is less or equal than 1 over 4x minus 3 is represented by this area here. Helpful hints. When you're graphing an inequality, make sure the test point is substituted into the original inequality. It is very important. You usually can get the test point 0 and 0 and go to the first line here and check the original inequality. Note that although all of our examples allowed us to select 0 and 0 as our test points, that will not always be true. If the boundary line contains 0 and 0, you must select another point that's not contained on the line as your test point. You can use anything, any point at all. But is not any point as long as it's not in the boundary line. Next objective, graphing intersections or unions of two linear inequalities. And let's have a look on the... This example asks to graph the intersection of x is less or equal than 2 and y is greater or equal than x plus 1. And I represented already the boundaries, right? And for x is less or equal than 2, let's check here. This is the test point, okay? 0, 0. 0 is less or equal than 2, true. So the area is this one that's where 0 is located, okay? This is the area for this first inequality in blue. Okay, this. And the other inequality in red, y greater or equal than x plus 1. Test points 0 and 0. 0 is greater or equal than 0 plus 1. Is that true or false? This is false, right? 0 is greater or equal than 1? No. So this is false. That means the area is going to be the one that does not contain the point 0, 0. That means this area here. And try, if you kind of confused, try to draw these graphs in different pieces of paper with the same dimension, with the same scale, and then you put one on top of the other, and try to see. Well, we want to know here the intersection, and the intersection of the graph is going to be the set that belongs to one inequality and the other inequality. That means the set or the area that belongs to both. And this will be represented by the area that has both colors, blue and red. This is the intersection. So you can check here, and I will, maybe it's going to be confusing, but I'm gonna represent this and I'm gonna show in purple. Maybe it's less purple. This line here is blue and red. Let's use the ruler. This is blue and red, right? This bit from here up is blue and red. And these other bits, these other segments, from this point of intersection here downwards is also blue and red. So the boundary of the intersection is going to be this segment of line up to this point, and then this segment of line here all the way to infinity. And the area is everything that's blue and red, which is the area now that I'm shading in purple. Okay, this is the intersection. And remember, we are representing just a small piece of the graphic here, and always important to remember that this goes all the way to infinity. Sometimes you cannot see, you cannot understand, or you cannot see this on the graph or on the PowerPoint, but this actually goes all the way to infinity. This purple representation here is everything that's red and blue, then is the intersection. And let's have a look at these slides. Graph the intersection of x plus 2y is less or equal than 4, or y is greater or equal than -1. Now, the word here is or. Or means union. First we graph each inequality. All right? Each inequality. And now, the result or the answer here for this example is going to be the union. But it's very important. Let me show something that the PowerPoint is not showing. Okay, let's do the test here for 0 and 0. 0 is greater or equal than -1. Is this true? Yes, it's true. That means everything on this side is dashed, is shaded in blue. And let's test now this one here for 0 and 0. 0 plus 2 times 0 is less or equal than 4. That means 0 is less or equal than 4. Is that true or false? True. That means the area that belongs, that contains the point 0 and 0 is going to be dashed. Here, the point 0, 0 is here, dashed. And finally, we are talking about union, or is this inequality or that inequality. And union is going to be all the areas that have some kind of color, some color. Blue, red, purple. And this situation here, the only area that's not colored, you're going to see is this. Let's make this purple. This one. This area here is white, and this goes all the way to infinity. So this is the only area that doesn't have any kind of color. It is not included in the union. Okay.